Okay, I'm going to look at the third part of question 1 from Thursday the 23rd class. So a couple of things here, given some parabolas. It says for functions of the form ax squared plus bx plus c, graph below, comment on the nature of the roots, the value of a, and the value of the discriminant. Okay, so the nature of the roots here, this is not crossing the x-axis. This is the x-axis in each case. If it does not cross the x-axis, then there are no real roots. But what we have is two imaginary roots. All quadratic functions will have two roots. Sometimes they're real, sometimes they are real, sometimes they're repeated. Here we have, there are two real roots here, and they're distinct, two distinct real roots, because it's crossing the x-axis in two places. Let's get rid of that. I had to get rid of it actually. Okay. Won't go away. So let me look back here. If there is no real roots, that means the discriminant is negative. If there are two distinct real roots, that means the discriminant is positive. Oh, I see this. No thanks. So we're going to look at the nature of the roots over here. Here we have just the x-axis tangent to the curve, the vertex right on the x-axis there. The nature of the roots here, we have two repeated, and they are real roots. And that happens if the discriminant b squared minus 4ac is equal to 0. And again, we've gone through all that stuff in class. The last thing I just want to mention is the value of a, the leading coefficient. For happy phase parabolas, a is positive. For sad phase parabolas, a is negative. Okay, so a bit of basic background information. Here we're given the same function again. It says find two values of p for which the graph will not cross the x-axis. So f of x will not cross the x-axis if and only if, well, if the discriminant is negative. If this thing, b squared minus 4ac, is negative, we will not have real roots if that happens. So if b squared minus 4ac is negative, b squared, 5 squared, minus 4 times a, which is 1, times c, which is p, if that's negative. And then I'm just going to solve this inequality. So I'm going to get 4p will be greater than 25. Adding 4p on both sides, squaring your 5, flipping the whole thing around. Which would mean p has to be greater than 25 divided by 4, which is 6.25. So for any value of p that is greater than 6.25, this graph will not cross the x-axis. And there's infinitely many values that are bigger than 6.25. However, p is an integer and it has to be between -3 and 8. There are only two integers in this interval that are bigger than 6.25. So two values. P is 7, that's an integer that's on this interval, or p is 8, that's also an integer that is on this interval. Okay?